did have a couple of these pop up in an exercise earlier, and some of you were using a bit of guessing and checking to find it, which worked for the easier types of questions. But we want to learn strategies that's going to help us with them as they get harder, as you can see as you look down this list of questions that we do today here. So exponential equations means that we're trying to solve for x when x is the power in the equation. Okay, so what we want to do is we want to manipulate those equations so that the bases on both sides are the same. Looking at the first one, looking at the very first question there, we have 2 to the power of x. So 2 is my base for that exponent. I want to try to rewrite the 8 as a base of 2 as well. So some of you will get your calculators out and you'll go 2 to the power of, what is it? 3, right? So 2 to the power of x is equal to, instead of 8, I'm going to rewrite 8 to be 2 to the power of 3 because that's equal to 8. But by doing that, I have made both on the left-hand side and the right-hand side of that equation bases of 2. Once the bases are the same, the powers have to be equal. So x on the left-hand side must be equal to the 3. Now that's the easiest type of question of these that you're going to get. They get harder from here. Part B though is not so bad. Have a look. We first of all on the left-hand side have a base of 3. Can we write 81 as a base of 3? Yes, I'm having fingers waved at me. Yes, power of 4. You check it on your calculator if you know, sometimes you're guessing, I think it might be a 3, I think it might be a 4. Type it in your calculator, 3 to the power of 4 does equal 81. So 3 to the power of x equals 3 to the power of 4. We're making the bases the same. Once the bases are the same, the powers must be equal, so x must be equal to the 4. Okay with that so far? Yep, good, all right. Part C, 2 to the power of x equals 1 over 8. Now 2 is clearly the base that I have on the left-hand side. The problem is on the right-hand side I have a fraction, which is less than ideal. But let's just take that 8 for a moment. Can we write the 8 with a base of 2? Yes, what is it? 2 to the power of 3 again. So let's change that to be 1 over 2 to the power of 3. Now we have been doing lots of work with indices. If I have a fraction and I have a 2 to the power of 3 on the bottom, if I want to get rid of that fraction, I can bring that whole denominator up and just give it a negative power. That's all I have to do. So 2 to the power of x is equal to 2 to the power of negative 3. That's using our index laws. So now that I just have my base of 2 on each side of that equation, the powers must be equal. So x is going to be equal to the negative 3. Still with me? Yeah. Good. All right, let's try that again. Part D is very similar. I have a base on the left-hand side of 2. So let's see if we can change that 16. Don't worry about the 1 for a minute. 2 to the power of what makes 16? 4. Very good. 2 to the power of 4 is 16. Now using my index laws, I want to get rid of that fraction by bringing the denominator up and giving it a negative power. So 2 to the negative x is going to be equal to 2 to the negative 4. Okay, again, I have the 2 on the left, the 2 on the right as my bases, so the powers have to be equal. On the left side, I have a minus x. On the right side, I have a minus 4. I can divide both sides by negative 1 to get rid of the minus sign, and that just gives me that x equals a positive 4. Yeah, still doing well? Great. Yes, Lily?
If you have, so if it's like a negative x, but the 4 was positive, would you still divide by negative 1?
Yes, to get the x by itself. Correct. Yes. All right. Question E and F. We're going to have to change our base a little bit more, for E especially. Okay? So we have a base of 4 on the left-hand side. The problem is, can I write 8 with a base of 4? No. Okay, 4 to the power of 1 is 4, 4 to the power of 2 is 16. There's nowhere in there without going to a decimal, we don't want to go to decimals, of getting an 8 with a base of 4. When that happens, it means I need to try and make both of the bases smaller. What do you think I should change them to? Bases of 2, that's right. They're both multiples of 2. So the 4 is the same as 2 squared. What do you think I should do with that x? I heard mumbling.
Put an x and 2.
Yeah. What's going to happen? We've got. I'll change this in a second. But we have 2 to the power of 2, and that's all to the power of x. But what's going to happen is you just time. When we have brackets with a power inside and outside, you just times those powers together, don't you? So it's really just 2 to the power of 2x. So we can just go straight to that. All right. Then the 8 with a base of 2. We've done this lots of times now. It's 2 to the power of 3, good. And now the bases are the same. Once the bases are the same, we make the powers equal to each other. So 2x on the left equals the 3 on the right. The bases just disappear. We're just making the powers equal. Then we're going to divide both sides by 2. So x is equal to 1.5 or 1.5 or 3 over 2. Any of those options, they're all the same thing. 1.5. Yeah, done. F. We have a base of 3 on the left. Can I write 27 with a base of 3? Yes. It is actually a yes. It's 3 to the power of? 3. Nice try. So, on the left-hand side, it already has the right base, so let's leave that one. On the right-hand side, 27 is 3 to the power of 3, and the x, remember, it's multiplied with that, so that's going to be 3x. Then, now the bases are the same. We can kind of get rid of those bases, and we just want to make the powers equal to each other. So on the top, I have a 2x minus 1, and on the right-hand side, I have that's equal to 3x. Okay, my power is a little bit messy this time, but that's a linear equation that we can solve. So all I want to do is subtract this 2x to collect up my x terms, and I will get -1 is equal to 3 minus 2, which is 1x, or we prefer to have our x on the left-hand side, so x is equal to -1. That's it. That's what we're practicing today, and that's the end of the topic.